सर ये एग्जैक्ट 12:30 बंद करना है या मतलब थोड़ा 10-15 मिनट ऊपर नीचे चलेगा?
सर बिल्कुल चलेगा।
चलेगा?
बिल्कुल चलेगा। इट इज एज पर योर कन्वीनियंस। पहले करना है, 10 मिनट बाद करना है, आधे 15-20 मिनट पहले करना है, 12 बजे के बाद अप टू यू, योर टाइम स्टार्ट।
ठीक है, ठीक है, ठीक है सर।
थैंक यू वेरी मच सर, थैंक यू। थैंक यू।
दीक्षित साहब, गुड मॉर्निंग।
गुड मॉर्निंग सर, गुड मॉर्निंग। कैसे हैं?
बस बढ़िया सर, आप कैसे हैं सर?
बढ़िया है, ठंड पड़ रही है।
हाँ, दिल्ली में ही है आप सर?
नहीं, आ रहा हूँ दिल्ली में आने।
अच्छा अच्छा, कहीं कहीं से आ रहे हैं आप रास्ते में?
नहीं, अभी वाराणसी में।
अच्छा, वाराणसी में। वाराणसी में तो ज़्यादा ठंड होगी।
हाँ।
राइट राइट।
और अच्छा है सब?
बिल्कुल बढ़िया है सर।
ठीक है सर, अभी मिलते हैं जो।
बिल्कुल बिल्कुल सर।
Very good morning to all. As per our Saturday's weekly seminar, today we have one another very important topic related with calibration and testing of energy meters. As we are all aware, these energy meters large in use in domestic as well as in commercial and the industrial sector. We have about more than 40 crores of electricity meters already used in our country. We have with us today one of our great expert, Shri B.M. Vyasji, who is having a lot of experience, Mr. Bal Mukund Vyas, who is working as Chief Scientific Officer at YMPL Yadav Measurement Private Limited Laboratory, which is one of the best laboratory in our country, having one of the state-of-art testing facilities in different sectors, gas meters, energy meters. They are known in the country, not only in the country, but at the international level. Mr. Vyas has done engineering in electronics in 1990s from MS University, Vadodara, Master of Business Administration from Sukhadia University, Udaipur. He is a techno-commercial leadership to TIC sector, electrotechnical and flow testing and calibration laboratory management skills. He is a lead assessor for ISO IEC 17025 2017, even earlier to that, the old standard, business development, service design expert, testing standard writing and standardization activities. He is a technical expert, member of committees in the BIS. He is an EMI, EMC reliability testing expert, proficiency testing in 17043 PT, which we are very well aware, electricity and gas meter testing as per IEC, EN, IS standards, as well as OML standards. Because I am aware he has done a lot of testing for our legal methodology also. So, and he has a lot of experience, started his career in 1990s from Secure Meters, which is also one of the great manufacturing facility in our country. And then from that, since 2004, he is working as the Chief Scientific Officer in the Yadav Measurement Private Limited. So, sir, thank you very much for accepting our request and delivering a talk on this topic, which is related with energy meter, because the people are aware how to do the testing, how to be utilized, what will be the uncertainty, how much is the maximum permissible error allowed as per international standards, as per IS standards, or as per OML standards. Thank you very much, sir. Thank you. We have with us our Honorable Shri B.N. Dixit, our Director Legal Methodology, sir, who has done a lot in the field of legal methodology. Everybody knows about him. I am not saying anything more because it will be just showing the lamp to the sun. He has done a lot of activities for the development of the legal methodology in our country. Sir, thank you very much for motivating us and always encouraging us to do good activities in the field of legal methodology. Thank you very much. Sir, I would like to request you to kindly speak 2 words.
Thank you, Ashutosh ji. Very good morning. Very good
Thank you,
morning
sir.
to Vyas Saab and all the participants who are participating in this very program, including all the peoples from RSL legal metrology officers and various scientists from the industry officers. Today, very good topic that is related with the energy meter. And energy meter is now these days playing very important role because from the mechanical side, now it is going toward the smart meters. So the smart meters are playing very important role. And in Uttar Pradesh and Delhi and other places, this many developed states, this Gujarat also, the smart meters are being installed in major cities. So that are the playing very important role there. So there is need of awakening about the smart meter and energy meters to the peoples also, because there are the many grievances which are coming in the newspapers. So I think that today topic is very good for the people of the country, and I thank Ashutosh ji to select these very topics. So by this the public will get a lot of advantage and the people will be aware about the energy meter and the smart meters. With these very words, I request Dr. Vyas to give his lecture, and thank you, Ashutosh ji, again and again. Thank you,
Thank
Ashutosh.
you, sir. Thank you, sir. Thank you very much for your kind and motivating words. Thank you, sir. Now I'd like to request our expert, Professor B.M. Vyas. Please, sir. Over to you, sir.
Morning, everybody, and I will start with big thanks to Ashutosh ji and Dixit Saab for very kind words. And as Dixit Saab has very rightly pointed out, this is a very recent topic of electricity metering. The whole world of electricity metering going through a lot of changes. Am I audible, sir?
Yes, sir. Very well. Very well. Please continue.
Good. So, as Dixit Saab has very rightly pointed out, throughout our country, the word of electricity metering is changing. Okay, so this topic is very important to understand. Government of India is pushing, and they have almost mandated to all electrical utilities that all old type of electronic meters should be replaced by smart meters. So this is one change in India, and government is funding to buy smart meters, and we will talk about what is smart meter, how they are different, and how they can be useful to us. We will talk a lot about various standards, what are their differences, what are their requirements, major tests and regulations. I hope my screen is visible.
Yes, sir. Yes.
Okay, right. Thank you very much. I will before going to the agenda, I will like to highlight here that electricity meter in our houses, because we all are consumers of electricity, and we all have electricity meters in our house, in our commercial establishment, or if we are working in an industry or we have our own industry, we have electricity meters ever. Without electricity, nothing is possible. But most of the time, what I have found is that we get electricity bills from the utilities, from our suppliers. Most people look at how much we have to pay. They don't pay attention to what is other information in the bill, how much units have we consumed, what are our variation to the units, what are the tariffs, how the total bill has been calculated. So it is not only important that we pay attention to only to the amount, but we have to pay attention to those things also. Another very important difference, we use a lot of electrical gadgets in our house, in our office, like TV, like mobile phones, and our washing machine, or lot of things. But there is a big difference between electricity meter and all these devices. All these devices are switched on and off as and when required. We might be on an average watching TV for, let's say, 2 hours or 1 hour or 4 hours on, and the rest of the time the TV is not working. Similarly, washing machine might be working for half an hour, 15 minutes in a day. Rest of the time it is not working. Unlike that, an electricity meter has to work 24 hours, 365 days. And that is the first interface to your electrical connection in your house or in your industry. So whatever electrical disturbances or any type of disturbances which you get from the electrical network, it is the first interface is the electricity meter, and they have to face all the disturbance. So this actually puts lots of reliability requirements and uh, high reliability requirement on electricity meter. It has to work 24 hours, 365 days accurately, continuously, without stop. And that is why electricity meter testing and calibration is very important. And I am also thankful to Asutosh sir for selecting this very hot topic. Okay, so now I start with, first I will start with what are different standards for meters. In India, we have Indian standards, which we mostly use, and all of you might be knowing that electricity meters are one of the device which Government of India, Ministry of Consumer Affairs, has mandated it to be ISI marked. So any meter which is manufactured in India or sold in India or used in India has to have BIS mark, ISI marking, as per one of these standards. So if it is a simple meter, most of the meters which we use in our houses are class 1 meter, which are BIS marked as per IS 13779, which is for AC static watt hour meters, active energy meters. If it is a CT operated meter, then it has to be tested as per IS 14697. Then there are standards for prepayment meters. Prepayment is one of the concept which was introduced in 2010, somewhere around 2010 in India, and there is a standard IS 15884 for prepayment meters. So the difference between a normal meter and the prepayment meter, as the name says, that you have to pay in advance. Like we recharge our mobile phone, the meter is also recharged for whatever amount you have purchased the electricity. And once that electricity is exhausted, you have consumed that amount of electricity, then it will disconnect your supply. And as soon as you recharge it, it will reconnect. So all these prepayment meter have a switch inside the meter, and to connect and disconnect. So that is called connect and disconnect switch, or it is a load control switch. And that type of meter has to be tested as per IS 15884. And there is a recent edition of this standard which was published in 2024. Another two standard, very important standard, are for smart electricity meters, smart meters. And there are two standard, IS 16444 part 1 and IS 16444 part 2. These two standards are for smart electricity meters. And part 1 is for direct connected meter, and part 2 is for transformer operated active and reactive meters. So these part 2 is mostly used for industry or grid metering, and part 1 is used for basically the domestic kind of meters. Now, what is difference between a smart meter and a normal meter? There are two major differences between a smart meter and a normal meter. One, the smart meter has a two-way communication capability. So two-way communication capability means meter can send the data to the utility head-end system. Head-end system means a computerized or system or a server which is in the IT department of the utility, the electricity supply authority. So meter can send data to the server, and similarly the server can send command to the meter. So this is two-way communication. Most of these smart meters can even send data almost every minute or even faster than that. So when smart meters are connected, the details about your consumption, details about your supply is online available to the utility, whether you are getting supply or not getting supply, whether you are consuming or not consuming, what is the status of your load, voltage, various situations, electrical situations, they are online available to the utility if a smart meter is connected. So that's one difference, that all smart meters have communication capability. Another important difference between a normal meter and the smart meter is it has got a connect and disconnected switch. So like in prepayment meter. So suppose you have not paid for the electricity bill, then if it is a normal meter, then the utility has to send a person to your house, and the electrician has to get on the pole and disconnect your supply if you have not paid. But this is not there. There is a smart meter, from the remotely the utility can disconnect your supply if you have not paid, and as soon as you pay, they will send a command to reconnect it. So that's the big difference between smart meter and normal meter. Then I will also like to talk to you about the international standards for metering standard. And one of the very important metering standard which is used worldwide is OIML R46, which is OIML, most of you might be knowing, is the International Institute for Legal Metrology and they make standards for not only energy meters, but for gas meters and various kinds of devices which we use in day to day for purchasing or for legal metrology purpose. So OIML R46 is one of the recommended document publication from the OIML, which is for active electrical energy meter. So this is also very popular standard for electricity meters. Then there are various IEC standards. IEC TC13 makes the standards for electricity meters, and they have these 5 types of standards. In fact, there is one more standard, 62052-11. It gives you general requirement, and then 53-21 gives you particular requirements for class 0.5, 1 and 2. 22 is for class 0.1s, 0.2s, 0.5s. So you can see there are standards up to 0.1 accuracy. These are mostly used for grid meters. And 53-23 is for reactive energy meters. There are 2 standards for reactive energy. One is 23 and one is 24. 24 is only for fundamental component of the reactive energy meters. If we talk about European requirements, in Europe, the electricity meters are also mandatorily has to be tested as per measurement instrument directives, and they have to be tested as per EN 50470-1, -2, or -3 standards. So these are given. They have slightly different type of accuracy classes, which they talk about class A, class B, and class C, which is similar to class 1, class 2, and 0.5. So as I told you, the electricity meter has to be a very rugged device. It has to work 24 hours, 365 days, and the life of electricity meters, mostly it is expected that at least more than 10 years it has to survive. So this means that the electricity meters, smart meter, or any kind of electronic meters, they are very rugged. They have to be tested very, very strictly. Various requirements. So I will be talking in general about various kinds of requirements which are specified for electricity meters in various standards. So if we see general testing, then standard electrical values, what are the values which are specified for meters? What are the accuracy test for accuracy requirements? So obviously they are very, very important. Metrology requirements has to be met. Then electrical requirements. So we will see all these requirements in detail. Insulation requirement, very important for safety. Mechanical requirements, climatic requirements, electromagnetic compatibility requirements. So we will see all those things. Specifically for smart meters, the supply and load control switch testing is very, very important, because switch, as I told you, is used for connect, disconnect, but it has to be very rugged switch. It should not fail, otherwise the supply to the consumer will be disconnected, or it will be connected permanently. So both are not good. Another important thing for smart meter, as I told you, is that it has two-way communication. So testing of communication protocol is also very, very important. So this is a kind of protocol which has been specified in IS 15959, which is based on IEC 62056 series of standards. So these are overall test requirements for electricity meters. Now let us look at each of these requirements in slightly details. So various kinds of standard reference voltages are specified for electricity meters. Depending on the country, they are selected. Like connection through voltage transformer, if a meter is connected through VT, which is mostly in industry or at grid level, then 63.5 volt is mostly used in our country. And if meter is to be direct connected, like in our houses, then or through current transformer also, then it has to be at 240 volt, which is mostly used in our country. And in some countries, it is used 220 volt, 230 volt, or 240 volts. So different voltages are specified. Similarly, the current ratings are specified for direct connection. The currents ratings are specified from 2.5 ampere to 50 ampere, and connection through current transformer is there, then it is only 1 ampere and 5 ampere, because this is what secondary of current transformers gives. Another very important requirements which has to be specified on electricity meter is maximum current. Maximum current is the value of the current which the meter will withstand, and also it will work accurately. So beyond maximum current, meter might be inaccurate also, and it might get damaged. And of course, the reference frequency has to be specified. Now, very important to understand is that what do you mean by class index? When we say class 1 meter, most of our houses are connected with class 1 accuracy meters. So in general, people will understand class 1 meter will have give the accuracy of my billing accuracy will be plus minus 1%. But actually, there is very important to understand the difference. What is class 1? So when class 1 is there, or class 0.5 is there, or class 0.2 is there, it means that the meter is accurate up to plus minus 1% from Imax to 0.1 IB or 0.05 IN to Imax for CT operated meter, unity power factor, when meter is tested under reference conditions only. So this is very important. So this accuracy class is defined under reference conditions. What are these reference conditions? 27 degree plus minus 2 degree. The voltage is within plus minus 1%. There is no harmonics, and so on and so on. Frequency is within limit, or so on. But what is difference is actually when we are using the meter in the field, we know the temperature will vary. We know there will be harmonics. We know there will be electromagnetic fields. So a lot of differences are there as compared to the reference condition. So obviously the billing accuracy which we are getting in our bill is not plus minus 1%. And we will talk this about further because all these influence quantities affects the accuracy of the meter, and of course there are limits specified for these influences, as we will see further. But what is important is to understand is that if our meter is not paid attention to, means it is not installed in good condition, it is installed at, let's say, very high temperature or at very low temperature, it is getting lots of harmonics, it is subjected to electromagnetic high frequency field, then it is not going to give me correct measurement. So this is very, very important to understand. In spite of being the accuracy meter has been tested for accuracy, it may not give you the correct measurements. So all these influence quantities will affect the measurements. So this is an example from IC standard, but of course these tables are very similar in Indian standard or even OIML standard. They are very similar. So you can see there are influences. Unity power factor. So when you say that it is meter is 0.5, it is plus minus 0.5 within this current accuracy only, 0.05 IN to Imax, right? For other current values and other power factor values, the specified accuracy limits are higher. So when we have said the meter is class 0.5, it is within plus minus 0.5 only in this current range at unity power factor, under reference condition, under balance conditions, and so on. So very important to understand this. Okay. So now let us talk about what are the accuracy tests which meter has to undergo before it is certified, whether as per OIML standard or as per Indian standard or as per IEC standard, depending on the which country we are working or the meter is there. But all these requirements are almost similar in all these standards. There might be differences in the limits, slight differences in the limits. There might be differences, slight differences in the test methods, but more or less they are similar. So of course meter has to undergo the limits of error due to variation of the current. So at different current when meter is connected, the load might be very small. Sometimes it may be full load, it may be 50% load, it may be 5% load, or sometimes there is no load. So accuracy of the meter has to be tested under all these conditions. Then all of you must have seen that there is a LED on the smart meter or electronic meter, and which keeps on blinking. What is that LED? That LED is actually a pulse output which is used for testing the accuracy of the meter. So if you are consuming more load, the LED will blink faster. If there is no load, then LED will not blink. And if there is less load, then LED will blink slowly. So the speed of LED is proportional to your power consumption or electricity consumption. And there is a meter constant written in the unit of impulse per kWh or impulse kVRh on the rating plate of the meter. The accuracy of that meter constant has to be tested, which is very important because that is used for accuracy testing of the meter. So there is a test for testing the accuracy of the meter constant. Another very important test is test of starting conditions. So meter should start with some particular load. So that is test of starting conditions, which are specified on the standard. Then there is a test of no load. No load means when there is no load, all your loads are switched off, then meter should not record any energy. So that is very important test which meter has to pass. Then repeatability of error, meter's error should be very repeatable. Ambient temperature influence. So when temperature is varying, how much error of the meter can vary? So that's ambient temperature variation. And limits of error due to other influence quantity. There are about 12 to 13 influence quantities which can influence the accuracy of the meters. So meter has to undergo all these tests. So let us see all these tests in slightly more detail. The first test is limits of error test. So you can see the current is being varied. So here you can see current is being varied, and when current is varying, the power factor also is specified differently in the standard, and there are limits specified for different value of current and different value of power factor. So these tables are similar because this is an example only given for 0.2 S class meter and 0.5 S class meter. Okay. Similar tables you will find in various standard OIML, Indian standards, and EN standard, and all those standards. So while testing the meter, the current is varying, the power factor is varying, and the accuracy against the reference meter is tested. The reference meter used should be traceable to national and international standards, and it should be at least 5 times better accurate. So if we are accuracy testing of the meter or the calibration of the meter of class 0.2 S, then overall uncertainty of measurement should be better than 0.04%. Another is test of meter constant. As I told you, the constant is the expressing the relation between the energy registered by the meter and corresponding pulse output. And the unit is watt hour per impulse or impulse per kWh, whatever is there. So accuracy of this meter constant has to be tested by passing through some specified load in the meter and counting the number of pulses the meter has given, and this relationship is verified whether this relationship is accurate or not. As I told you, the meter is tested for starting conditions, means for minimum value of the current. Like suppose in our houses we are charging the mobile phone, so the current consumed by mobile phone for charging is very, very small. In that case, whether the meter is registering, because even mobile phone is also consuming the energy, so that has to be recorded. So there is a specified minimum starting current, which is specified in the standard, and typical value is 0.1% of IB. IB is the basic current. So that amount of current is passed to the meter, and it is checked whether meter has started recording the energy or not in the register. So this is test of starting condition. Another test, as I told you, is test of no load condition. So when there is no load connected to the meter, no current is passing through the meter, in that case, the meter should not register any energy. So that is the requirement, and the time for which the test engineer has to wait to check whether meter has registered energy has to be calculated as per these formulas which are given in this screen. So there are two different formula, and this time is almost come out for different current ratings and different voltage ratings. Sometimes it can be for 15 minutes to sometimes you have to test it for 45 minutes or so. Then another important tests are repeatability of error. So because you know the uncertainty of the metering is dependent on how meter is repeatable. So repeatability of error. So error of the meter is tested for, let's say, 5 times or 6 times at different load conditions, and the 20 successive error samples at different intervals of 5/30 minutes is taken, and the difference should be less than half of the accuracy class. Another very important test is test of ambient temperature influence. As I told you, mostly the meters are installed outside the houses. Nowadays, you must have seen that meters are installed on the poles also. So when meters are installed under such harsh condition, meter has to face sometimes very high temperature. Sometimes meters are working under direct sunlight. And sometimes they have to face very low temperature also. So it is important that the accuracy of the meter is not affected, and also it is within limits. Any change in error of the meter because of this temperature range should be controlled. So this is the test which ensures that meter's accuracy is not highly affected by temperature. So accuracy of the meter is tested at different temperature in environmental chamber, and the variation in the error is compared with the error at 25 degrees centigrade or 27 degrees centigrade, which is the reference temperature, right? So test of accuracy requirements, and then other influence quantities. So as I told you, meter has to face lots of other influences in the field. So ambient temperature, we have already said. Voltage variation, which is very important, because as you know, the voltage in our house or even in industry is not constant. It is varying. So if I take example of our house, normally we should get 240 volt plus minus 6% as per electricity act, electricity rules. But we find that sometimes voltage is 260 volt, sometimes even at 180 volt. If you go to villages, even it is sometimes very low voltage is there. So accuracy of the meter has to be maintained in all these voltage variation conditions, and the standard specifies that how much error can vary with these voltages. As I told you, this is there in OIML and Indian standards. Similarly, frequency can vary. So normally our frequency should be 50 hertz, but sometimes it can vary by plus minus 5%. So how frequency variation can affect the accuracy of the meter, and the limits are specified in the standard. Phase sequence reversal. So this is applicable for three-phase meter. If you have a three-phase meter, then phase sequence can be RYB or it can be RBY, and it is specified in the standard that this change in phase sequence should not affect the accuracy of the meter more than specified limit. Voltage unbalance. So as voltage can vary, if it is a three-phase meter, voltage unbalance can also happen. So in one phase, you have 250 volt, in another phase you have 200 volt, and in third phase maybe you have 220 volts. So this is all voltage unbalance. So under these voltage unbalance conditions, the meter's accuracy should not get affected beyond the limit. Another influence is DC and even harmonics. So when meter is operating, we see that in our houses we use lots of electronic devices like even laptop or like even TV, washing machine. All these devices have not perfectly 50 hertz load. They are operating on switch mode power supply or on diode based supply or on thyristor based supply, SCR based supply. Then they do not consume load with exactly 50 hertz. They generate the currents with harmonics. So meter under reference condition, it is tested as, with a current of exactly 50 hertz and sinusoidal voltage without any harmonics. But here we are testing that how meter's accuracy is affected if there is a DC content in the meter, in the current, or the current has harmonics, even harmonics. So this is even harmonics. So in this case, there is an harmonics only in current circuit. There is no harmonics in the voltage circuit. In the next case, we are testing the meter's accuracy when there is a harmonics present in both voltage and current circuit. So how the meter is measuring the energy when there is harmonics or subharmonics or the odd harmonics present in the load and voltage circuit. Another very important is DC magnetic field and AC magnetic field. So these tests have two types of reasons behind why these tests are conducted. Because when meter is installed, because there are electrical wiring around that, and there will always be present some of the magnetic field, and it can be DC also, and it can be AC magnetic field also. So this magnetic field should not affect the accuracy of the meter. But another important thing is that we have found that many people try to temper the meter or make it slow using very heavy magnetic fields. So in India, there is a requirement of testing the electricity meters with a bit of heavy magnetic fields, for example, 0.5 Tesla DC magnet or 10 millitesla AC magnet and so on. So such type of accuracy testing is there, and these meters have features to record the tempering using the magnets. So meters, even most of the smart meters have magnetic sensor, and if somebody tries to temper the meter with the magnet, the meter will record, and a smart meter will instantly inform to the utility engineer that this particular meter is being tempered. So this is very important tool in smart meter. They have facility to record the temper, and because they have ability to communicate instantly, they will immediately inform. And many utility are using this feature to stop the temper. And you know, most of our utilities are facing lot of tempering problem, and they lose revenue because of this. So this is very useful feature. Another is electromagnetic high frequency field or EMI/EMC influences. Because electromagnetic high frequency field, you know, we have almost everywhere we have high frequency field. So this is very important test. So meter is kept under high frequency field, and accuracy is tested, and various accessories. So this table actually gives you how all these influences, the error limit with respect to the reference condition, variation in percentage error because of all these influence quantities, it is allowed. Similar table is there in all metering standards. This picture is actually giving you that how magnetic field influence is tested. So in the first picture, there is a magnetic coil of 1 meter, and meter is kept at the center. Current is passed through this coil, and AC magnetic field is created at the center of the coil, and meter's accuracy is tested. Similarly, you can see in the second and third, the magnetic coils are there, and meter's accuracy is being tested at different magnetic field, 0.5 millitesla, 0.2 Tesla, and so on. So another requirements, as I explained, is about electrical requirements. Within electrical requirement, meter has to tested for power consumption, the influence of supply voltage, short time overcurrent, influence of self-heating, heating, and earth fault. So power consumption, because meter is an electronic circuit, so it itself also consume the power. So that's the power. Suppose as Ashutosh sir told in the starting that we have 40 crore meter, and if each meter is consuming 1 watt, you can imagine how much power can be consumed itself by the meter throughout the country. Okay, so there is a limit in the standard on how much power the meter can consume. Remember, the power consumed by meter is not measured by the meter, so it has to be paid by the utility. So you are not paying for the, as a consumer, we are not paying for the power which is consumed by the meter itself. So there are various limits specified for smart meters or a meter with communication circuit. There are because if meter has a communication circuit, then more power is required. So the allowed limit for smart meters are more than normal meters. Another test requirements for electricity meter is how it behaves when there is a voltage dip or interruption. So meter should be able to withstand the supply interruption or voltage changes, voltage dips. Sometimes voltage can dip up to 50%. Sometimes it can interrupt for few, let's say for 1 second, and then it can restore. Under such type of very quick interruptions, the meter should not get damaged. It should work correctly once supply is restored, and its data should not be corrupted. So data should be maintained. So that's the requirement for supply voltage dips and interruption. So there are various types of dips specified in the standard. So dip can be for 1 cycle, which is 20 millisecond, or it can be for 1 minute. So various types of dips are specified, and the meter's accuracy has to be tested before and after that. Another very important test requirement is short time overcurrent test. This is very important from the 2 point of view. One, the meter should withstand the short circuit, and also it should not cause any fire in the house. So because there can be fault in electrical network in our house or in our industry, when there is a fault, a heavy current flows through the electrical network, and the same current is passed through the meter also. So it should not happen that if there is a short circuit in our house, then meter get damaged or its accuracy is affected. So a short circuit is created, and the short circuit current is passed through the meter, which is half cycle for the whole current meter and 0.5 second or say 25 cycle for CTPT operated meters. And it is seen that meter is not causing any fire and it is not damaged, and after the test, after the short circuit, the meter's accuracy is not affected beyond a particular limit which is specified in the standard. So you can see here the various types of short circuit current waveforms. On the left side, you can see this 25 cycle of short circuit current, which is used for short circuit of CTPT operated meter. On the right hand side, you can see the half cycle short circuit current. And these are the various test equipments which are used for testing the short circuit on the meters. There are different tests to be done for a smart meter with a switch. The switch has to be tested with prospective load current, load short circuit current, and you need different types of equipment for testing the smart meter switch. Another important test, electrical requirement is test of influence of self-heating, because meter has an electronic circuit and the current is passing through the meter, so there is a heating in the meter, and this heating should not cause uh, the changes in the accuracy of the meter and should not get damaged. So there are limits specified for the self-heating, change in error because of self-heating. So in this test, initially the meter is powered up for 2 hours without any current, and then accuracy is tested, and after that the maximum current is applied to the meter at UPF also and 0.5 power factor also, and then the accuracy of the meter is tested for every 20 minutes until it gets stabilized and the variation is checked. So you can see various tests it has to pass through. Right. Another series of tests which meter has to pass through is test of insulation properties, which is basically for safety for the users of the electricity meter. So if it should not happen that if there is a smart meter or a normal meter, if you are trying to read the meter, you are trying to see the display of the meter, you should not get shock. Similarly, if a meter reader is coming on in your house, or somebody is coming to inspect the meter, or somebody is coming to test the accuracy of the meter, because the accuracy of the meter can be tested at site also. They should not get shocked when they touch the meter for push button or connecting the supply and so on. So insulation of the meter has to be properly tested. Most of the meters which are used in our house and mostly in industry, they are having reinforced insulation, means there is no earthing requirement on this. So the insulation of those meters is tested up to 4 kV as per AC high voltage test requirements. The insulation also has to pass through impulse voltage, because there can be impulses in the electrical network. And as I told, electricity meter is the first device which faces all these impulses. So let us see what are different tests. So this is the first test for impulse voltage, and typically it is 6 kV of impulse which meter has to face. This is 6000 volt impulse waveform, which is this type of waveform, which is shown here in red. So it rises at very fast rate and then it reduces. The typical rise time is 1.2 microsecond and the fall time is 50 microsecond. So this type of impulse meter has to pass through. Another test, as I told you, is for AC high voltage test. So high voltage is applied between the body of the meter and between all other terminals. So the outside body of the meter is
Oh, good morning. How are you?
Hello.
Well done.
Hello. Please
Can you get for me the
mute.
exercise book?
Please
Within,
mute.
yes.
Hello.
Okay, just buy for me. All right.
I would
Thank you.
request if somebody can mute those who are speaking.
Please continue.
mute
It is
your-
done. It is done.
Right. Thank you very much,
Thank
sir.
you, sir. Thank you.
So another important test is AC high voltage test, which is for personal safety, and this test duration is 60 seconds, which is 1 minute. And as I told you, if it is a reinforced insulation type of meter, then a 4 kV test is to be applied. But sometimes if there are rack mounted meters, then meter has the earthing provision. In that case, if there is an earthing provision, then meter can be tested for 2 kV of insulation, because there is an additional safety measure of earthing. And of course, so this is about 2 kV and 4 kV test requirements between other circuits, between the circuits also. If there is a safety SELV circuit, they also has to be tested for the insulation. Another test is for insulation resistance measurement, which is similar to the AC high voltage test, but the test is done at 500 volt, and the insulation resistance of the insulation is tested, and there are various limits specified. That is between, on one hand, all current and voltage circuit as well as auxiliary circuit connected. On the other side, it is earth. The limit is 5 mega ohm. And between circuit which are not to be connected together, the limit is 50 mega ohm. This is applicable, for example, for CT operated meter, where there has to be an insulation between voltage circuit and the current circuit. So these were all insulation requirements. So as you are seeing, that meter has to pass through lots of tests before it is approved by BIS mark or legal metrology or CE marking or MID marking in international market or domestic market. Another very important requirements are mechanical requirements. So meter should be mechanically rugged right from meter is manufactured, then it is packed and then transported to the utility store, then it is tested in the utility, and then it is transported to the place where the meter is to be installed. Then it is installed, and then it is used. Sometimes meters are installed in boxes, but sometimes they are not installed in boxes. So keeping in all this view, there are various mechanical test requirements which are specified in the standard. Spring hammer test. So meter body should be subjected to an impact hammer, and it is seen whether it is rugged or not. Ingress protection, as I was telling you, that sometimes meter are installed outside our houses with box, without box. Sometimes you might have seen that meter are installed on the poles. So meter is subjected to dust, to various types of pollutions. Meter is subjected to rain. And all those things. So in body has to withstand ingress of all these pollutions via water and dust. Another test is resistance to heat and fire. So meter plastic, because mostly it is now plastic which are used in the meter body. So the plastic should be of engineering quality so that it does not catch fire immediately, and it does not help in spreading the fire. And then of course meter has to withstand the shock and vibration which meter will face during transportation. So there are various tests for mechanical requirements. This is the spring hammer. So you can see a spring hammer which is specified in various standard. This is specified as per Indian and IEC standard, as per IEC 9000 standard in Indian standard. So the energy which is imparted on the meter body is 0.22 Newton meter as per Indian standard, and 0.2 joules as per IEC standard. So the meter body, the display cover, they are all subject to this type of spring impact, and it is seen that it is not causing any damage to the meter, or inside the meter there is no damage to the electronic circuitry when such type of impact is there. Then of course meter is subjected to dust test and the water test. So environment may be dusty, there can be rain, and both of these can not only affect the electronic of the meter, but it can also affect the insulation level of the meter and can make meter unsafe. So during the ingress protection test, after the ingress protection test, meter is subjected to insulation tests. So for testing the dust protection, there we have to use a dust chamber, and typically the meters, indoor type of meters, are specified for testing as per IP51. IP is ingress protection, and 51, the first numeral 5, uh, specify the dust protection level. 5 is dust chamber, specified small size dust meter is subjected to, and then meter is opened and seen if there is a ingress of dust inside the body of the meter. So the first digit of IP51, which means 5, 5 specifies that the how much is the accuracy, how much is the protection class of the meter for against the dust. The another numeral y, x and y, 51 means 1. 1 specified the protection level from the rain. So this you can see 1, 2, 3, 4, 5, 6 specify the various levels from the dust or solid objects. So meter is specified to be tested as per the 5th level of the dust protection. So meter is put inside a dust chamber. The dust is circulated in the chamber for 8 hours, and after 8 hours, meter is taken out and it is subjected to the insulation test, and meter is opened and it is seen if there is any ingress of dust inside the meter. So in short, meter should be dust proof. Against the water, the meter is subjected to artificial rain. So there is a rain testing machine, and if meter is to be of indoor type, means or it is to be installed in a box, then it has to pass through the first level of the rain protection, or you can say water protection. So meter is subjected to artificial rain, and then it is after the test for 10 minutes. After the test, the meter is subjected to insulation test, and meter is again opened and see if there is a water ingress in the meter. So meter should be waterproof up to level of 1. If it is a outside meter, outdoor meter, then meter is subjected to 4th level of the test, which is spray nozzle. In spray nozzle kind of test, the meter is subjected to a spray of water with meter rotating in different directions, from top side, from the front side, from the back side. The meter is subjected to a spray of water as per specified standard, and then meter is subjected to insulation test and opened and seen if there is an ingress of water. So these are the tests for ingress protection of the water. Another important test for mechanical requirement is meter is subjected to shock. So you can see there is a shock testing machine shown here as a pic on this. Meter is mounted on this platform of the machine, and machine actually subjects the meter to the specified shock. Typically, the shock level is 30 G. 30 G means 30 times the gravitational acceleration, which is 300 meter per second square. So meter is subjected to the shock with a duration of 18 milliseconds of the shock, and the shock is applied in different axes. And then meter is checked for accuracy and its performance, that it should not show any damage or change in information. It should give us the correct reading. Of course, then meter is subjected to the vibration test, because when meter is being transported, or sometimes even when meter is installed, at that point of time also there can be vibration at the installation site also. Suppose it is installed in an industry or a commercial environment, or the transportation vibration and so on. So meter should withstand, and its accuracy and its performance should not get affected because of this vibration. So the vibration, transportation vibration, which is specified is 10 Hertz to 150 Hertz with a transition frequency of 60 Hertz, which is for constant amplitude and constant acceleration. And there are 10 sweep cycles from 10 Hertz to 150 Hertz, then 150 Hertz to 10 Hertz, and so on. 10 such cycles are meter is subjected to. So this total test actually lasts for 75 minutes. So meter is subjected on a vibration machine for vibrations for 75 minutes, and after that meter is tested for its accuracy and any damage in the meter. If there is a damage and change in accuracy, then it is not a suitable meter. So these pictures are showing you vibration, and the vibration is done in all three axes of the meter, X, Y, and Z. As the meter can face vibration in different angles also. Another very important test for the meter is resistance to heat and fire. As I was explaining you, the plastic, if meter is made of plastic, that this test is applicable. There are two different types of plastic which can be used in the meter. One is for its terminal block where the wires are connected, because those are the areas where the heating can be more. Another plastic which can be used is for terminal cover or for meter body. So two different temperatures are specified. One is for terminal block where wires are connected. Because of load, there can be more heat. So the temperature limit specified is 960 degrees centigrade for 30 minutes. So the terminal block plastic is subjected to this type of temperature, 960 degrees centigrade, which you can see on the right hand side the picture. The red hot iron meter is subjected to, the terminal block is subjected to, and it is seen that if the terminal block is catching fire, if it is catching fire, then within how much time it is self extinguishing. It should not be that it should take more than 30 seconds to extinguish the flame. And if the terminal block should not burn and it should not melt and fall down. So you can see there is a tissue paper, white tissue paper placed below this glowing element, and if the terminal block is melting and the drops are falling on this tissue paper, then it is not considered as a suitable plastic. So this is the test, and similar test, except that the temperature is 650 degrees centigrade, is tested on or subjected on the meter case, terminal cover also. So this actually controls the quality of plastic. A normal plastic cannot be used on electricity meters. It has to be a good quality engineering class plastic which passes through this test. And this is very important. You see that many times we hear that there is fire in complexes, and if the quality is not good, then meter also can cause fire. Another test which meter has to pass through is climatic requirement. So as I was telling, that meter can face very high temperature, meter can face very low temperature. So we have to ensure that the meter is not affected, its functionality and its accuracy is not affected because of this temperature, and also the humidity condition. So damp heat tests. The two tests, cold and dry, they actually simulate the storage conditions. When meter is being transported or when it is being stored, suppose you are transporting the meter through ship or through air, it can face temperature as low as -25 degrees centigrade and as high as 70 degrees centigrade. But of course, when meter is being transported, it is not in operating conditions. So the cold and dry test, they are done with meter in non-operating conditions. So no voltage is applied or no current is applied to the meter. So if it is an indoor meter, then meter is kept at -25 degrees centigrade for 72 hours. And if it is an outdoor meter, then it is kept at -40 degrees centigrade for 72 hours. So after 72 hours, the meter is again tested for its accuracy and functionalities. Similarly, for high temperature, it is subjected to 70 degrees centigrade for 72 hours. So these two tests actually simulates the storage of the meter. During storage, meter's accuracy and its functionality are not affected. And another test for climatic requirement is damp fit test. So in damp fit test, meter is in normal operating condition with voltage applied but no current applied, and it is subjected to high temperature and high humidity. So the upper temperature is for indoor meter is 40 degrees centigrade. For outdoor meter, it is normally 55 degrees centigrade with an humidity cycle. So humidity is uh, kept at somewhere around 93%, plus minus 3%, and it is varied between the cycle. And this test actually goes for 6 days in an environmental chamber. After the test and after 6 days are completed, after 24 hours after that, the meter is subjected to insulation test, and of course the meter's accuracy and functionality should not get affected. Okay, then another very important test nowadays are basically is electromagnetic interference test. Meter itself is an electronic device, and of course meter is subjected to lots of electromagnetic interference. So one of the very common noun is like we use mobile phone. So how mobile phone works based on radio frequency. So radio frequency is there in the air in everywhere. We have mobile towers. If meter is very close to an airport, then there can be radars frequency. Then there are satellites, then there are police communications and so on, Bluetooth, Wi-Fi. All these are electromagnetic field. They create electromagnetic field in the air, which meter also sees. And because meter is an electronic device, if it is not designed properly, it might malfunction. So electromagnetic interference, so this is one kind of electromagnetic interference. Then there are various kinds of other electromagnetic interferences like surge, like electrostatic discharge, transients, and so on, which is shown here. So our power line also causes electromagnetic interferences. The natural phenomena like lightning also cause electromagnetic interferences. Our TV broadcast, radio broadcast, ships, radars, walkie-talkie, mobile communication, even the electrical gadgets like our mixer in our house, or TV, or inverters, or the electric motors, and so on. All these devices, they create electromagnetic disturbances, which we can tell as electromagnetic interferences. So this can affect the performance of the meter. So this is shows you various kinds of electromagnetic interference. So there is a term called electromagnetic compatibility. Means electromagnetic compatibility means that the product has to function as per its desired performance in this electromagnetic environment. So ability to devise equipment or system to function satisfactorily in its electromagnetic environment without introducing intolerable electromagnetic disturbance to anything in that environment. So when we define electromagnetic compatibility, there are two aspects. One, the device should function satisfactorily, and it should not cause disturbance to other devices. So it should not happen, because your meter is electronic meter, and when meter is installed in your house, it should not happen that your other devices in houses are malfunctioning because of meter. So meter itself should not emit electromagnetic field or electromagnetic disturbances which causes problem to other electronic device. For example, suppose meter is working and then your laptop is not working, or your Wi-Fi is not working, or your Bluetooth is not working. So it should not happen. So there are two different requirements as far as electromagnetic compatibility is concerned. One, it should function in the presence of various kinds of electromagnetic disturbances satisfactorily, and it should not cause disturbances to the others. So this one is called immunity and another is called emission level. So on the left hand side, you can see immunity is specified, which is the ability of device, equipment or system to perform without degradation in the presence of an electromagnetic disturbances. And on the right hand side, you can see emission limit, the unintentional release of electromagnetic energy from an electronic device or apparatus. So there are limits specified. The emission limits are typically specified in standards which are called CISPR, CISPR. So this standard series, which also works very closely with the IEC, the emission limits are specified in CISPR standards, and the immunity testing as from various kinds of disturbances are specified in IEC standard, and IEC has very specific series of electromagnetic immunity disturbance testing, which is called IEC 61004 series, DES4 series, and we will see this. So again, this is presented here. Electromagnetic compatibility means electromagnetic interference testing, and another is electromagnetic susceptibility testing, or which is also called immunity testing. Again, because electromagnetic field or the RF field can travel through cables, which is called conductance, and it can travel through air, means radiated, air or vacuum. So this is called radiated. So all these electromagnetic interferences are tested in two conditions. One is radiated, another is conducted. Similarly, the immunity is also carried out in radiated and conducted mode. So when we talk about immunity, the radiated, there are three types of radiated fields. One is radiated susceptibility, which can be tested in an anechoic chamber or in a G-tail, or there are power frequency magnetic fields. Conducted disturbance, various types of conducted disturbance can be there: surge, electrical fast transient burst, electrostatic discharge, damp oscillatory, ring wave, voltage dips and interruption, and there can be conducted radio frequency disturbance within 2 kilohertz to 150 kilohertz. So as I mentioned, these IEC 61004 series of standards. So these are various standard test methods which are specified, and the meter has to pass through all these tests as per IEC 61004 series. And CISPR 32 actually specifies for radiated emission and also for conducted emission. So this specified that how much radio frequency can be emitted by the meter. So what is the limit specified in this CISPR standard through air or through cables connected to the meter. After the test or during the test of this electromagnetic immunity test, the various types of evaluation criteria are specified, which is called A, B, C, and D, as in various standard. So one is A is normal performance within limits specified by the manufacturer. B is temporary loss of function. So under certain electromagnetic situation, it is allowed that meter can lose its function temporarily, not permanent. In C kind of situation, temporary loss of function or degradation of performance, the correction of which requires operator intervention. So this is C. So C and D are not allowed for electricity meter. The meter, for meter it is allowed only A. Evaluation criteria is only A and B. So now let us see in slight detail what are these electromagnetic interferences. So first is electrostatic discharge. So electrostatic discharge is a typical kind of voltage which is generated in our body, human body, when we are walking on a carpet or simple walking, or we are sitting on a plastic chair. Our body generates charge. You might have faced that sometimes when you touch a metallic body, you get a very small shock. That kind of voltages are very high voltage, though the energy level is very small to damage our body, but the energy level is sufficient to damage the electronics in the meter. So the voltage levels can be as high as up to 35 kV, 12 kV, 6 kV, 20 kV, 18 kV, and so on. And this voltage is dependent on the humidity. If humidity is high, the voltage level will be less. If humidity is low, like in winter, the electrostatic voltage in our body is highly generated. Like this is, if you are your body is charged with a specified voltage and you go and touch the meter, then all the energy which is in your body is discharged, high voltage is discharged on the meter, and it can damage the electronics of the meter. So meter is subjected to such type of electrostatic discharges. So there are specified electrostatic discharge guns available as per IEC 61000-4-2 standard, and this is the typical setup which is specified in this standard for testing the meter. Meter is placed on a table which is 80 centimeter height. There should not be any other metallic body around the meter, and the electrostatic discharge actually discharges the high voltage waveform on the meter. Various openings, displays, meter is subjected to this. And also when this electrostatic discharge happen, the heavy current will also flow, and this, because the current is very high, means it can be few kiloamperes. This current will generate magnetic field, high magnetic field, and meter should not get affected because of this magnetic field. So there are two types of tests. One is direct discharge of the electrostatics, and another is indirect discharge. So in indirect discharge, the high voltage is discharged on a metallic plate which is kept close to the meter body, 10 centimeter away, and the heavy current will flow through this metallic plate, and which will cause the magnetic field, and the performance of the meter is checked due to this discharge. So you can see here at various points discharges are applied, air discharge, and if it is a metallic point, then contact discharge is applied. So these are the voltage level for electrostatics: 2 kV, 4 kV, 6 kV, 8 kV, and meter has to pass through up to 8 kV of contact discharge and 15 kV of air discharge. Another test, electromagnetic high frequency field. So this is the kind of field which I was talking about, is generated because of our mobile phones, mobile tower, or antennas or radars of this Bluetooth, the Wi-Fi. They are all generating the radio frequency field in the air. So to test so this is various sources of radio frequency field shown here: TV broadcasting, mobile network, radio broadcasting, navigation, satellite, and so on. To test the immunity of the meter against this the kind of radio frequency field, which can be from 80 megahertz to few gigahertz. right? Uh, and you might have to test up to 6 gigahertz. You see the Wi-Fi which we are using in our houses nowadays is working at somewhere around 5 gigahertz. The Bluetooth which we use is works at 2.4 gigahertz. The mobile phones, they typically work at around 1000 megahertz, or sometimes even up to 1800 megahertz. So the air around us is full with all frequencies of radio frequencies field. And this field can be of the range of 30 volts per meter. Okay. So to test the immunity of meter against this kind of radio frequency field, a special chamber is required, and very expensive chamber. This type of chamber can cost us around sometimes around 5 to 8 crore of rupees, and it has an antenna. Picture inside of this chamber is a picture is shown here. You can see various kinds of blue conical. They are actually radio frequency absorbers. This chamber is called anechoic chamber. Anechoic chamber means any radio frequency which is generated inside this chamber is when it subjected, the walls are subjected to this radio frequency field, they are not reflected back. No echo is there as far as radio frequency is concerned. So the walls and the ceiling of this kind of chamber is made in such a way that they absorb almost 100% of the radio frequency. So there is no echoing. So this is called anechoic kind of chamber. Another important thing is, when this test is being conducted, it should not get influenced by the outside radio frequency. So this chamber is totally shielded against the radio frequency. So when meter is kept inside this chamber on a turntable, which is rotating, which can rotate 360-degree, uh, the any radio frequency from outside this chamber cannot get into this chamber, and similarly no radio frequency from inside the chamber can get out of this chamber. So this is fully shielded. So you can see the meter is placed at a particular place, and you can see a horn antenna. This horn antenna is generating the radio frequency field, and this radio frequency field is imparted on the meter from 80 megahertz to 2000 megahertz and so on. If we can test up to 6000 megahertz, 6 gigahertz, and frequency is increased with a 1% step size, and the field can be for the creep test, the field can be of 30 volts per meter. Means when 30 volts per meter kind of field at different frequency is there, the meter should not start recording. When there is no load, should not start recording energy automatically. And another kind of test, again same kind of field, which is 80 megahertz to 2000 megahertz. The field strength is 10 volts per meter, and the accuracy of the meter is tested in the presence of this kind of field. So this kind of field, generating this kind of field requires different kinds of antenna. This is very expensive test and also time consuming. So you require the antenna has to be kept at 3 meter distance from the meter itself. So this is a big chamber, very expensive test, and only 1 meter can be tested at a time, because if you keep 2 meters, then there can be influence of 1 meter on the another meter. So this is a very expensive test, and it takes sometimes more than 10 hours to do complete the testing 1 meter. This test can also be done in another kind of device, which is called G10 cell, which is relatively cheaper, but there is a size limitation that maximum 30 centimeter kind of meter can be tested in these kind of chambers, G10 cells. So various kinds of field strengths are specified as you see in IEC 61000 for this 3. Another test is electrical fast transient test. So when meters are installed and there is an electrical network, so when switching is there on the electrical networks, especially in grid situations, you have circuit breakers, you have isolation devices. When they are operated, there are fast transients which are generated on the electrical network, and they can travel through cables to the meters. So relay, solenoid valves, washing machine, electric fans, switch, contactor, heavy duty motors, they all can generate transients which can damage the meter or which can affect the accuracy of the meter. So these voltages can be of the range of 4 kV or sometimes even higher with respect to the earth. So both power connection to the meter and the signal and control ports to the meter are subjected to these kinds of transients. So this is a typical electrical fast transient test setup, which is again, this is one of the very expensive test, and it has to be tested with specified distances from the metallic.
Sir,
And
your voice is very low.
hello, now is it now better?
Okay, sir. Please continue.
Sir,
It's
the
okay, sir.
voice is low.
Okay. Okay,
Please
thank you,
continue.
sir.
You think you have to increase your volume because otherwise at our side it is okay. Thank you, sir. Please continue.
Okay, right. Thank you. So this is fast transient test. Another kind of test which meter has to pass through is the lightning surge. Lightning surge, sometimes you might have noticed that when there is a lightning surge, our devices in our houses are also damaged, and sometimes you see that our supply get disconnected because there are problems in the substation and so on. So the lightning surges can be very damaging to the meter and other devices. So meter has to pass through this lightning surge. So this is a typical lightning surge type kind of setup. This is a surge generator, lightning surge generator, which can generate lightning surges up to 15 kV, and the meter has to pass through these tests as per IC 61000 for days 5. Typically 4 kV surge is specified. In Indian standard it is 6 kV, but what we have seen is that in areas, for example in Odisha or in coastal areas like Mumbai, the surge level is very high. So my recommendation is to test the meters to a surge level of at least 10 kV to ensure that they work very reliably in the field. Another test, which as I was telling, is emission test. So how much meter is emitting the radio frequency? So there are two kinds of test. In fact, three kinds of test, that is conducted emission, radiated emission, and radiated power disturbance can also be measured using absorbing clamp. So this test is done as per CISPR 11 or CISPR 32. So depending on the configuration of the meter, this standard is selected. One of the method to do this testing is to use an open area test site, but nowadays it is very difficult because open area test site should be at a place where their surrounding electromagnetic interference is not there, and nowadays it is very difficult to find out such type of open area test site because we see that electromagnetic interference is available everywhere. So most of the time this kind of test is done in anechoic chamber, the similar kind of anechoic chamber which I explained for electromagnetic high frequency immunity test. So this is electromagnetic anechoic chamber. Similar to what I have shown, the chambers are used for even testing aeroplanes or fighter planes, right? So this is one kind of radio frequency measurement, RE measurement. You can see the meter is placed on a turntable. The steel turntable, you can see circular turntable, and meter is rotated with 360 degrees centigrade. And the antenna, you can see a biconical antenna on the left hand side picture. This antenna measures the radio frequency which is being emitted by the meter in the air, and this antenna gives you information how much radio frequency is emitted at different frequencies by the meter. And there are limits specified in CISPR standard and energy meter standard as per BIS and IEC standards. So various kinds of antenna are used for different frequencies. You can see precision log periodic antenna is used for 300 megahertz to 1000 megahertz. Biconical antenna is used from 30 megahertz to 300 megahertz, and the horn antenna is used from 1 gigahertz to 6 gigahertz. Again, this is a very expensive test because you can test 1 meter at a time, and it takes you have to rotate the meter in the 360 degree at different angles, small angles, and you have to find out where is the peak emission. And then once you identify the peak, then you have to test for Cauchy peak and average radio frequency. So that is why this takes a lot of time. And the equipments used for this kind of radio interference measurements are also very expensive, and these are the limits. You can see for 30 megahertz to 230 megahertz, the limit is specified is 30 dB microvolt per meter for Cauchy peak, and from 230 megahertz to 1000 megahertz, 37 dB microvolt. And for higher frequency, the average limit is 50 dB microvolt per meter, and from 3 to 6 gigahertz it is 54. Similarly, you have to carry out conducted emission measurement. That is, conducted emission measurement is how much meter is emitting in the cables. So you can see here the picture for testing measuring this type of conducted emission. You need a line impedance stabilizing network, and the meter is connected with the cable, and that cable is connected to the EMI receiver. So this EMI receiver is measuring how much radio frequency meter is emitting in these cables. So this ensures that meter is not disturbing the devices which you are using in your house. So this is a typical graph from starting from 150 kilohertz to 30 megahertz, the how much meter is emitting. So this kind of measurements are there. Similar kind of test can be done using the absorbing clamp as per CISPR 14-1 or IS 68773. So this kind of arrangements can be are used for measuring the radiated emission from the meter. So this also specified the radiated power as per IS 6873. This is similar limits specified. Typical fault occurs during EMI-EMC test, means these are various kinds of faults which can happen in the meter. Meter blinking can happen, display can get hang, microprocessor malfunctioning can happen, memory data can corrupted, measurement accuracy can be affected. It can detect invalid faults, invalid tampers, communication failures can happen, garbage data transmission can happen, metrology, memory, battery can get affected, and so on. So these are various IS metering standard. I have already explained you, and these meter has to pass through all these EMI-EMC tests which are mentioned here. So this is again shown various kinds of EMI-EMC tests. So on in different standard, what are different EMI-EMC tests are specified here. So I am just skipping this. So this is just detail, right? Uh, all of you must have noticed that Vets and Measure Department has issued a GATC regulation on electricity meters also. In fact, this is applicable for about 18 instruments. For example, gas meter, electricity meters, BP instruments, and so on. And this legal metrology GATC amendment rule 2025, this also covers for electricity meter, and it requires, because this is a gazette issued by government of India, it requires that all meters should be verified before they are installed and at periodicity which is specified in the meter. And GATC means government approved test center, and Vets and Measure Department is going to uh, authorize various kinds of government approved test center. This process has already been started, and I'm sure soon legal metrology department will approve the government approved test center to test various kinds of electricity meters and gas meters and other devices. So this is very important gadget which will help consumers in
Tienes spedito il
ensuring.
tanto niente, muy tinto, muy
Excuse me, please mute. So this is very important regulation which has been issued by Vets and Measure Department, and this will ensure that the accuracy of billing which we are getting as a consumer is accurate and meters are functioning correctly continuously. In addition, the Ministry of Power has issued quality control orders as per various metering standard, and this actually ensures that the meters are ISI marked. So it is mandatory in India, if there is a meter which is manufactured or used, all kinds of meters has to be ISI marked as per various standard which I have already explained, and this gives you various quality control orders. So that is why this quality control order ensures that all meters are ISI marked, which ensures that meter passes through all these tests which I explained, and it is a reliable quality meter. So with this, I complete. If there are any questions, I can take up. Asutosh ji.
Thank you very much, sir. Thank you. It was wonderful presentation. I would like to request you to kindly share me this presentation and kindly unshare the
Sure, sir.
slides. I would like to request all the participants to kindly switch on their videos so that we can take few photographs for our social media. Sir, I would like to request you to kindly share me this presentation. After this PPT,
sure.
after this program, the whole video as well as this PPT will be uploaded on our website jagograhakjago.gov.in/seminars. This is already mentioned in our all programs, all leaflets, all certificates. So kindly you can go through this. My request is, sir, if you can unshare this PPT, please.
Let me see. Stop sharing.
Yeah, stop sharing.
Yeah.
Thank you, sir. Thank you very much.
Thank you very much, sir.
Thank you, sir. Sir, I will share this PPT as well as this video on our website as well as on YouTube channel. The participants can be benefited. It was wonderful exercise, but my request will be, because it is a new topic, I would like to request you to kindly once again take a lecture and explain how to do the calibration. Today we understand a little bit theory, how to do practically, how to go in the laboratory, how to take a meter, how to do the EMI EMC test, how to do the accuracy test. Kindly do, if we, with the help of few videos or few photographs, if you can explain, it will be a very good help to the whole country.
Definitely, sir. It will be my pleasure to do this.
Thank you. Thank you very much. Because, sir, this is a new field, and I think that many of us are may not be aware how to do this testing, even at the laboratory as well as at site, how to do the verification. So with this, I would like to thank our Honorable Professor B.M. Vyas Saab and Dikshit Saab, with all the participants. NIC team and other all without you it cannot be possible with these programs. So we will meet again next week on next Saturday with a new topic. With this, I would like to thank all the participants. Thank you very much. Thank you.
Sir, I would like to ask one question, very simple
Thank you very much.
question. Yeah,
Please, please, please,
I'm
please,
from
please.
Consumer Education Research Center, Ahmedabad, and
Yes,
we
yes,
would
yes. I
like.
have a CERC.
Yes, yes, sir. Uh, so we would like to establish the testing as per GATC. So for application, we have some of the problems, and these are like, can we have the limited facilities at GATC for testing of energy meters? Because the way Dr. Vyas has explained it is fantastic. Like, I mean, all the type is the meter should confirm. But for GETC, what are the most important tests? That's very important for us.
Actually, for the JTC, we are only concerned
Hmm.
about the calibration.
Yeah.
So we have to go for the testing. As you know, EMI, EMC, lot of tests which
Yeah.
he's doing. It is basically for the pattern approval or for other tests. But for calibration, all these tests are not required. Certainly, that's why I requested Professor Vyas to make one another presentation how to do this calibration and what is the difference between the calibration or the verification and the testing. So one another program we will be shortly, and this will be very good for all the participants. Thank you. I think Mr.
Hello.
Okay, thank you very much.